Hey guys, what's up? So, today I'm going to be teaching you guys some basic kinematic physics. So, it's all theory that you need to get through for motion in a straight line. So, it's the basics of kinematics. So, we're going to be looking at what speed. So, today's lesson overview. We're going to be looking at, scalar quantities, vector quantities. We're going to be looking at speed, distance, time, velocity, speed, distance, time, velocity. We're going to be looking at the kinematic equations, so the 5 different equations. And then we've also been looking at everything in between. So let's get started. This video is kind of new, as in it's very new. It's my first time making such a video ever. Connecting my iPad to a TV that's never been used before in the garage. Yeah, okay. So, as soon as I log onto my computer, let's get started. Okay, we're in bed. So, we're not going to waste time anymore. Let's get started. Yeah, hopefully you guys can see clear and all. Sorry for the ratio aspect. This app doesn't support it. As in, suppose I go to GoodNotes, right? It'll fill up the page. But it's just that the app I'm using doesn't support it, so sorry guys. So, no sorries, no more things. Let's get into the video, okay? Okay. When you're first attacking kinematics, right, you want to really understand two main things. It's centered around two main things, this motion in a straight line. Those two main essential basic ideas are scalar quantities, S-C-A-L-A-R, and vector quantities, vector, okay? So, these are your two main quantities that you want to go over, alright? Your scalar quantities and your vector quantities. All good. Now, let's look at scalar quantity. What is a scalar quantity? Sorry. A scalar quantity is a quantity that has a magnitude. So it has a magnitude. And let's very quickly look at what a vector quantity is. A vector quantity is one that has both the magnitude but also has directions. So let's just say plus directions. So a scalar quantity just has magnitude. A vector quantity has both magnitude and directions. So that's the main difference. Okay. Now, let's dig deep into the scalar quantities section. So, inside the scalar quantities, what are some examples of scalar quantities, right? Well, one obvious one is distance. Okay? It's alright if you do not know any of this, just keep watching. Distance. And one obvious vector quantity is displacement. I mean, I'm just starting off physics in year 11. I'm not sure how important these are, but from my seniors, kinematics is something that's going to stick through the entire way through physics. Doesn't matter if you're doing waves, doesn't matter what you're doing. You got to really solidify your understanding on these and not forget them ever. I mean, I'll probably forget them, that's why this video, but okay. So, distance. So, distance is a form of scalar quantity. What is SI unit, you might ask? Well, SI unit is S. Why, you might ask? I don't know. That is distance. So, what is distance? Well, let's go smaller. A distance is the length between point A and point B. A, B. So, distance is just basically the length between the A and the B. So, if we draw a line, it's the line there. It doesn't necessarily have to be a straight line. It could be the path that you took, right? You could have went to A to B in this parabolic shape. It's all right. That's your distance. So that is what distance is. Okay. It's sometimes referred to as path length in questions. Distance and path length are things that can be used interchangeably. So keep that in mind. Now, talking about distance, we should not forget about speed. Alrighty? Because speed is crucial to scalar quantities and distance and all this. So let's talk about speed. Okay? Speed. And then on the other hand, of course, we got to talk about displacement, but we also got to talk about velocity. Okay? So these are the two next main important attributes. So let me just go ahead and highlight this for you. Okay, now let's highlight it. Let's look at what speed is. Speed is basically, how do I describe speed? Okay, speed is the rate of change of distance. That's why these words are included. It's the rate of change of distance. So it's basically distance over time is equal to speed. So that's that formula that you would all know from the, DST triangle. But speed in its essence is the total distance traveled divided by the total time you traveled it for. That's how we get the average speed. Alright? So let me just see what speed is though. I forgot. No, not really forget. I told you the thing. Speed is the rate of change distance. What is speed physics? Okay, speed refers to how fast an object can be moving. Rate of change through which an object covers an answer. Okay, I'm basically right. It's the rate of change of distance. As in, and what's the SI unit for speed? You might ask, it's V. Alright? The SI unit for speed is V. I know it's very confusing, like, okay, velocity V. Just keep it. Distance, SI unit is S. Speed, SI unit is V. Alright? Okay. Now, keeping the big picture still in mind, speed, as we know it, is the S is known as V. Remember, guys? I made this mistake so many times. V is equal to speed over time. So V is equal to speed over time. Easy. V is equal to total speed over the total time. What the hell am I saying? The speed is equal to the total distance divided by the total time. Okay. Now with our framework starting to look somewhat understandable, let's go and talk about different factors inside speed. When you're learning about speed, you're going to be learning about average speed, instantaneous speed. Let me look. Average, instantaneous, yeah. Those are the two things that we'll be looking at. Average and instantaneous. Badly for my handwriting. I don't really feel in the mood to, have the perfect handwriting right now, but okay. So that is instantaneous. Let's look at what average speed and instantaneous speed are. Average speed, it's such a pain having to change all these nib sizes. Average speed is the, what do you call it? Average speed is, the total distance over the total time. So it's the distance interval over the time interval. Now, I know all this sounds crazy, but just keep this in mind. V, AV, so average speed symbol is V, average is equal to distance interval over the time. Oh, what happened there? Okay, I'm going to manually erase this. That's not going to count. So distance interval over the time interval. Now you might be wondering, so Cash, what is this distance interval time interval? Okay, let's take a step back and let's look at this distance interval thing. So let's branch out from distance and we're going to be looking at distance interval. Distance interval. Okay, so the distance interval is basically d2 minus d1. So it's basically the amount of distance that you've traveled in an interval. So suppose this is your journey and this is point A, point B, point C, and you want to find something just particularly for this thing. Suppose you want to find the speed just for between A and B, then the distance interval is B minus A, which will give you this length. And the time interval is measured in the same way. But I made one big mistake. That is, I forgot to write time in the middle. Time is a major deal here. Time. Okay? Because time not only is involved in distance, speed, velocity, and displacement, it's very crucial. Time is in the center of all of these abstract topics. But these are not really abstract, because as we're working our way through this mind map, in the end, you'll be able to identify all the relationships and you'll be able to fully store this in your brain. Okay. Let's look at instantaneous. We looked at what average speed is. Average speed is the total distance interval over the total time interval. That will give you the average speed. Now, what is instantaneous speed? Well, instantaneous speed by definition is the speed at the instant. I'll repeat. Instantaneous speed is the speed at a particular instant. So this instantaneous speed can be usually measured by something like, your car speedometer or the laser guns that the police have. Instantaneous speed is speed at a particular instant. Okay, so that's basically this side of the portion. That's basically the scalar quantity side. That's almost done. Let me just double check. Yeah, that's the scalar quantity side, almost done. Now let's go look at the vector quantity stuff. Now, tell me what a vector is, if you still remember. Good. Yes. Vector is something that has both the magnitude and the direction. So something like, 50 meters, suppose that's just the magnitude. A vector quantity would be like 50 meters east, or they would have plus minus signs, depending on the scenario and the situation. Okay, that's vector. Let's look at displacement. What is displacement? Displacement, let me explain it to you. Take points A and point B. Okay, point A and point B. Remember how you displace your distance if you travel like this is the total length you went. It's total path length that you took. Displacement, in simple terms, is the shortest path from the end point, from the start point to the end point. Or to make it more technical, displacement is the position of the displacement is the position of the endpoint relative to the origin. Okay, suppose displacement like this. Displacement is the position of an object relative to the origin. Okay, keyword relative to origin. I know this is all fancy super maths, but you want to put this in your exam, right? If they ask you what displacement is, you want to say displacement is the, position of an object relative to origin. Because what does relative to origin mean? Let's say you're at B is your position, it's relative to origin, displacement is the straight line, the shortest length, right? When you say relative to origin, it makes the marker think you're smart. It's just relative to your A, when you first started, okay? Just keep that in mind. Let me shrink to resize, shrink it down, close to that. Okay. Now, I think that's displacement already. If you want to make some notes on this mind map as it is, do so while I haven't done videos in a long time, so I guess I need a lot of water. Okay, let's look at velocity. Alright, when you look at velocity, we have the same two things: instantaneous velocity, average velocity. for our cases, we don't really want to dig into instantaneous velocity because it's the same thing. It's velocity at an instant. Let's go. I think I need the size 3. Okay, that's right. Average velocity. But then here we have a new variable. It's called relative velocity. And I'll get into relative velocity in just a second, but give me a few minutes. And let's talk about distance interval as well. I don't think there is much explanation needed. Interval. Okay. Yeah, distance interval. So, okay. All good. So, oopsie daisy. So, what is this distance interval? You might be asking. Distance interval is basically same like the distance interval. So the displacement interval is similar to the distance interval, which is d2 minus d1. Here we're just going to use some different terminology so that we don't get it mixed up. So let's use x1 minus x2 minus x1. So it's basically a displacement of a minus a. x2 minus x1. There's no real use of knowing these terms, but I'm just telling it to you because it's in the syllabus, it's in the curriculum, it's in the textbooks. It's bloody everywhere. Okay, let's look at average speed now. What the hell am I saying? Let's look at average velocity. And of course, my laptop goes off again. Pa-pow, pa-pow, pa-pow. What the hell's wrong? Why does everything have to go in my favor? Okay, let's look at average velocity. Average speed is the distance time interval over the time interval. But because we know velocity is basically, what do you call it? The rate of change of displacement. So when we say rate of change, just use the symbol delta, which is this triangle symbol. You might have seen it in math, but just use this symbol, right? Delta. That's what delta is. So delta displacement. So it's the rate of change of displacement, right? Yeah, I got it right. So what's the SI units for both displacement and velocity? I forgot to mention that. Displacement's velocity, SI unit, is the same as distance at S. Velocity is the same as speed, V, except because these are vector quantities, we have vector arrows on top of them. That's the main difference that you're going to use to differentiate between, this is the displacement, this is the distance, this is a scalar, vector, blah, blah, blah. Okay? You just want that vector arrow on top. Okay. Now let's look into average speed, average velocity. Knowing what velocity is, what is velocity? It's the rate of change of displacement, as in it is the displacement interval over the time interval. Similar concept to the thing, but now don't get confused by all these interval blah 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 blah. Just go take your displacement. Take your displacement for that area. If they say points, car, lorry, car, truck, take the displacement of that. And then take the time interval. And yeah, V vector arrow, that's the average velocity. Now what is this relative velocity? Because for velocity, instantaneous is the same. Okay. Relative velocity. Relative velocity is the wait, let me say it to myself first. Okay, relative velocity is the velocity of an object relative to the ground compared to the velocity of the observer relative to the ground. Absorb that in. It's the velocity of the object relative to the ground minus velocity of observer relative to ground. So let's write it down. Velocity of object relative to ground minus velocity of observer relative to ground. Okay, all this is fancy, fancy, fancy. Even I don't understand this relative velocity shit fully. So let me go ahead and talk about frames of references just for a second, right? Frames of references. Okay, cool. Now we can talk about frames of references. Now, what is this frame of reference? Sorry, I was just thinking about KGO for a while and oh man, my brain went berserk. Look, I've summarized it here for you guys. A frame of reference right? It's the point of the observer taken of the observer. Let me rephrase it. It's the point taken by the observer of the observation. So it's the point taken by the object of the observer. Similar to that. So why is this frame of reference important to know? Well, let me demonstrate its importance. But just before I go ahead, just keep this in mind. Nothing in the universe is an absolute motion or absolute rest. And I'll elaborate on all this right now. So what is frames of reference? It's basically how you view something. Suppose you're in a car. Okay? Suppose you're in a car. Yeah, a nice car like this. Suppose you're in the car and you see a, person on the road. If you're in the car, if you're the person in the car, right? Okay, why does this look so scary? Okay, if you're the person in the car, you are moving at a stationary speed, right? You're a stationary object. Because when you're in the car, imagine yourself. You're not moving. You're stationary. Your surrounding is moving. So let's say if you're going at 50 kilometers an hour, like this guy is going backwards at a 50 kilometer per hour speed. So for you, you are the stationary object. Your initial velocity, you'll say 0. You're the stationary object, right? You're at rest. You're stationary. Because you're not moving anything. You're going at a constant speed. But this guy is going back at 50 kilometers an hour. Okay? And let's say you're the guy. You're the observer now. In your eyes, you're stationary for the observer, right? He's stationary. The car has gone by at 50 kilometers an hour. So this is frames of references. It's different viewpoints of different people. And there's always going to be multiple frames of references. There's no one correct frames of reference. So that's where relative motion and all this jump into play. Yeah. Let's just ask ChatGPT. Hey, what's the difference between relative velocity and frames of references?
Relative velocity is how fast one object is moving in relation to another. Frames of reference are the different viewpoints we use to observe motion. So relative velocity is about the speed between objects, while frames of reference are the perspectives we use to measure that speed. Anything specific you're curious about?
Now, can you repeat that again, please?
Sure. Relative velocity is about how fast one thing moves compared to another. Frames of reference are different viewpoints for observing motion. So it's like measuring speed between objects and the perspectives we use to do that. Anything you want more details on?
No, sorry, ChatGPT, can you explain that again?
Absolutely. Relative velocity deals with the speed of one thing in relation to another. Frames of reference are different viewpoints we use to observe motion. It's like measuring how fast things are moving relative to each other and the perspectives we choose to measure that speed. Anything specific you'd like to dive into?
Can you give me an example of relative velocity?
Sure thing. Imagine you're in a car going 60 miles per hour and a bicycle is moving at 10 miles per hour in the same direction. The relative velocity of the bicycle from your perspective would be 50 miles per hour, 60 minus 10. It's like looking at how fast one thing is moving.
Shut up. Sure thing. Imagine you're in a car, 60 miles per hour, and a bicycle is moving at 10 miles per hour in the same direction. The relative velocity of the bicycle from your perspective would be 50 miles an hour, 60 minus 10. Okay, right. Now, that's interesting. That's really interesting. Because all this time, I thought they both were the same thing. No, they're not. Relative velocity is the way or the different perspectives you look at speeds. And frames of references are your different perspectives. Okay? So that's why for relative velocity, we subtract the velocity of the object relative to the ground minus the velocity of the observer relative to the ground. That's how we get relative velocity. So if you're going in a car and then you see a bike, right? You subtract the bike, you take the bike first and then you subtract yourself from it because you're the observer. If you're going in a car and you see a bike coming and going in your direction, you want the relative velocity. Let's say the bike is going at 10 minus you're going at 50. That's what you're going to do. 10 minus 50 minus 40. Okay? Okay. Now, I think that's basically all the theory that we need to know. Oh no, my bad. There's one more, and it's acceleration. It's our final one. So, let's look at it. In fact, if you didn't know, I mean, you probably don't. I didn't know too. Acceleration is a vector quantity, alright? A-C-C-E-L-E-R-A-T-I-O-N. So anytime you see the acceleration graphs, acceleration anything, just know it's measured in velocity. Because anything that's a vector quantity will be measured in velocity. Anything that's a scalar quantity will be measured in speed. Alrighty, speed, distance. Here, velocity, displacement. Store that in your brain. Now, what is acceleration? Acceleration is the rate of change of velocity. How unique? Rate of change of velocity. So it's how fast or how the velocity changes. Yeah. So, for acceleration, right? Suppose you're slowing down, okay? You're going in a car and you're slowing down. That's accelerating. It's not really accelerating, you're decelerating, but it's part of acceleration. Negative acceleration. And then suppose you're speeding up. Speeding up. This is what many of us know to be true. As acceleration, you're speeding up, you're accelerating. Exponential. And this one tricks a lot of people. It doesn't trick them, but it doesn't come to their mind at first. Change in direction. Yes, change in direction. Now, yes, it's weird, but just let me explain. Acceleration is a vector quantity, right here? And what is vector known for? Vectors are known for having the magnitude plus direction. So a change in direction will result in you accelerating by the law of physics. So as per the book, if you turn right, you are accelerating. All goody? All good. Now we know the fundamentals. Let's look at the kinematic equations. Funny fun! So it's important to remember that these kinematic equations only stay true if the acceleration is constant. And for most of your high school physics, at least prelim, it will be constant. So when they're constant, we have a number of equations we can use. So the first one, very simple. It's, the velocity, initial velocity, final velocity minus initial velocity over time. So A is equal to V minus U over T. This is the one we all know. Acceleration is equal to final minus initial over time. Now, let us let's find the same acceleration thing, but in terms of T. Okay? No, my bad. In terms of V. So when we find it, we get AT is equal to V minus U. And then, take V to the other side. V is equal to U plus AT. Oh, goody. This is therefore our second equation, right? V is equal to U plus AT. Okay. Now let's look at our third one. Our third one is a little special. It is V is equal to 1. No, I'm not going to write it in the form that the school gave us. I don't know why I'm making a big deal on myself. It's U plus V over 2 T. U plus V over 2 T. And we have 2 more to go. This one is displacement or distance, whatever you like, is equal to UT plus half AT squared. And our final one, V squared is equal to U squared plus 2AS. Okay, so these are all our kinematic equations. And with that, folks, I think our first part of the video is done. This is the mind map that we have right now. Feel free to improve this. Let me just make some relationships clear. Final relationships clear. So, velocity and acceleration, well, they're related. Then, we know that the speed and velocity are also actually related, right? So, speed is not fully what you think it is. Speed and velocity are actually interconnected, right? Speed, velocity. What's their main connection, you might ask? Well, it's just the fact that both of them, when you refer to them, you write it as ms minus 1, or otherwise pronounced as meter per second. You write meter per second as meter per second minus 1. Let's say when we're defining something like acceleration, you're going to write meter per second, or meter per second minus 2. That's the SI unit there. Okay. Then we have a relationship between average velocity, average displacement. I don't think we do. Wait, my sources are telling me that I do. Ah, okay. All they're saying is that average velocity and average displacement produce to form uniform motion. This is what we call uniform motion. Okay? Well, that's pretty useless. But anyway, guys, if this is our basic rough and work teaching mind map, it basically has every content that you need except for the graphs and the proofs of these kinematic equations, which I will be posting in the next videos. Yeah? Alrighty. Calm down. Kinematic equations, proofs, it's coming. The graphs of, stuff like velocity time graph, position time graph, acceleration time graph, what's the relationship between each of those? It's all coming. Just wait. With that, I'll be gone. Take a photo of this if you want. And do ensure to comment below how you like this new approach. I don't know if this worked out or not. So let me know.